A forget bonus, the true story lies beneath our feet. This is Ichnology, the science of trace fossils. And it captures movement, a ghost of lifelong past. Bones tell us what they were, tracks tell us how they lived. Now that we understand the scope, let's explore formation. The creation requires precise conditions, soft sediment, followed by rapid preservation. This initial depression becomes the trackway, a profound behavioral record. And later stages involve overlying sediment hardening into rock, capturing the shape. The resulting trace fossil is the preserved impression of the dinosaur's contact. But preservation isn't always simple. Molds and casts complicate interpretation. On the mold is the impression, the cast is the infilling sediment. Now that we understand formation, let's explore gait and speed. But trackways are essential for measuring stride length and pace. Long steps suggest a fast, confident gait, indicative of energy expenditure. Regular spacing might imply hesitation, injury, or changing terrain conditions. Depth variation also correlates directly to the animal's mass at that moment. The morphology of the print itself reveals the foot structure underneath. How we can differentiate herbivores from carnivores based on print characteristics. Claw marks or ungual impressions are crucial evidence for predator identification. Many dinosaurs utilized all four limbs during slower movements, like grazing. Now that we understand gait, let's examine social dynamics. Trackways that run parallel suggest organized group movement. This confirms herding behavior, a strategy for defense and migration. Overlapping prints imply tighter formation or potential disturbance within the group. Conversely, widely spaced, erratic tracks often point toward solitary or stressed animals. We observe subadult prints tracking near larger individuals. Parental care evidence. Ichnology allows us to reconstruct these transient social moments precisely. Now that we understand behavior, let's consider paleoenvironmental clues. Sediment type dictates how clearly the dinosaur foot leaves its signature. Ripple marks within the prints reveal water flow direction and energy. Desiccation cracks around the margin tell us the environment dried rapidly. Tidal flat environments are prime locations for preserving these sequential records. Sometimes, smaller traces tell us about the local microfauna interacting. Erosion is the persistent enemy, constantly threatening these fragile paleosignatures. Understanding these layers is key to unlocking temporal depth in ichnology. Mineralization patterns can also help date the preservation event itself. Now that we understand environment, let's see how scientists interpret this data. An Ichno taxonomy categorizes these traces based on consistent recurring patterns. Modern animal locomotion studies serve as essential comparative benchmarks for interpretation. Specialized casting materials capture the fine detail before weathering intervenes. The resulting cast becomes a tangible, storable record of that singular moment. Every tiny imperfection on the cast aids in rigorous scientific classification. And these detailed records ultimately furnish museum exhibits globally. The data fuels complex biomechanical models of extinct giants. Collaboration across fields is vital for maximizing the information extracted. Modern laser scanning provides three-dimensional data beyond human measurement capabilities. This digital map preserves the track's geometry eternally, independent of erosion. We can now digitally walk in the footsteps of the past. Now that we understand data collection, consider the implications for extinction. A sudden cessation of all track production signals catastrophe. The absence of new dinosaur footprints speaks volumes about immediate environmental collapse. This contrast starkly illustrates the functional world before and after the impact. That final dinosaur footprint represents the last known physical evidence of their walk. Ichnology provides context for the biological record we often treat as static. But these traces reveal global distribution patterns across ancient continents. On every single track is a unique snapshot of time and gravity's effects. And we trace the continuity of biological mechanics across eons. Ichnology reminds us that the Earth was once utterly alive beneath our feet. These fossilized steps are not just impressions, they are dynamic narratives. And in those preserved steps, the giant world walks with us still.